Hi, welcome to this description of the Laughing Music Rental Services operational database. The purpose of this database is to provide users access to music and pay the musicians who created it. The database has 5 logical clusters. In the center is the song cluster that includes the songs with descriptive information about them. A song includes the title of the song and how long it is. In the upper right is the users cluster that keeps track of users and their contact information. Users provide telephone numbers and an address. Users also keep a wallet in the system so that they can purchase music. In the lower left is the performers cluster that identifies the individuals involved in the creation of a song. The performers get paid directly for the rentals of the music they've created. The database tracks what role each individual has played in a song. The lower right has discovery information such as user reviews and song ratings. In the upper left is an accounting cluster that keeps track of billing for the songs and paying the performers. The accounting cluster keeps track of tax information for each payee and information for rental transactions. In this discussion, I'm going to focus on part of the song and performers cluster. Each song comes from multiple performers. In a given song, each performer, called artist, can play many roles. For example, in this song by Blue Oyster called They're Different Artists with Different Roles. This information is kept in a ternary provenance relationship that is connecting song artist and the roles they play. The entity relationship diagram for this relation centers on the provenance table. It has three one-to-many relationships to define the participation of each entity. Provenance is a bridge entity to implement the logical ternary relationship. First, the song table contains information about each song. This includes the song title, duration of the song, and whether the song is visible to users or not. The foreign key P-note ID connects to pricing information for the song. The one-to-many relationship comes from means that each song can have many provenances. A second relation is with the artist table. This performs relation connects to a table with only 2 foreign keys. The name ID key links to the name of the artist, and the payee ID identifies who is to be paid from the song's rental. This performs one-to-many relationship means that each artist can have many provenances. Each artist must have a corresponding name that is located through the name ID foreign key. Finally, there is a role entity giving the name of each role. Because the primary key of a provenance is a composite key of the song ID, artist ID, and role ID, each provenance entry must have exactly one of each. In addition, each triple of song, role, and artist can only be stored once. I'll walk through the actual connection of primary keys and foreign keys for the song entity. Here's one provenance instance and its primary keys and foreign keys identified. The first instance that it'll get connected to is song. This connection is made through several steps. I've stripped down the tables to just show a single instance. Logically, the connection is found first by selecting the tables, then identifying the relationship that's being retrieved. From there, the primary key and foreign key related in the relation can be identified. The values are matched, and then we have a record from the song entity, too much information as being the song is part of this provenance record. A similar process finds that the name associated with this provenance is Simon Le Bon, and that the role he played in the song was as writer, or at least one role he played was writer. So this is the basic information that the provenance entry provides. The song Too Much Information comes from Simon Le Bon, who was performing writer in that song.